Quiz 8 solutions for Math 95. In the first two problems, we're asked to multiply. So the way to think about this is we're multiplying something with two terms, something else with two terms. So essentially we have to FOIL is the acronym most people use. Another way to think about it is you can do it kind of using this box method. Essentially this is the same as FOIL, except this method will work when you have more than two terms, whereas FOIL kind of just works when you have two terms in each of the things that you're multiplying together. And then fill in these four boxes, and that will be the product of these guys. 1 times the square root of 3 is just the square root of 3. 1 times the square root of 6 is just the square root of 6. However, the square root of 3 times the square root of 2 takes a little bit more doing. It turns out it's the square root of 6. Where that comes from is this is essentially 2 to the 1/2 power, and this is 3 to the 1/2 power. When you're multiplying together two things that have the same exponent, you just multiply the bases. 2 times 3 is 6, and raise that to the exponent 1/2 power. Anyway, square root of 2 times square root of 6 would be the square root of 12 by that same logic. So what I get is that this thing is equal to root 3 plus root 6 plus root 6 plus root 12. But I can simplify that. You can say it's root 3 plus 2 of these square root of 6 things, plus it turns out that the square root of 12 is 2 times the square root of 3. If you're wondering where I got that, it's because the square root of 12 is equal to the square root of 4 times 3, and 4 is 2 squared, so if I do my little good radical, bad radical trick, on the good side I'll put 2 squared, and on the bad side I'll put a 3, and the square root of 2 squared is just 2. So that's where this guy came from. So I got root 3 plus 2 root 6 plus 2 more root 3s. I got 3 of these root 3 things plus 2 of these root 6 things. Maybe this is how I got that. Alright, enough arrows. Next one. Multiplying together square root of 3 plus the square root of 6 times the square root of 3 minus the square root of 6. You could do it like this if you wanted to, or you could recognize that you have what are called conjugate pairs. In other words, I'm multiplying together two things, and those things are kind of the same, root 3, root 6, root 3, root 6. The only difference is in one of them I'm adding the two together, and the other one I'm subtracting them. Turns out that anytime you multiply conjugate pairs, they multiply in a special form. You end up with the first thing squared, so the square root of 3 squared. Square root of 3 squared is just 3, minus the second thing squared. Square root of 6 squared is just 6. So 3 minus 6 is just negative 3. That ends up being my final answer. I think recognizing conjugate pairs will save you some time. You could have done it this way, though, and you'll get the exact same answer. Rationalize the denominator. All right, the way you rationalize denominators is essentially it's making it so that you don't have square roots in the denominator anymore. So for this first one, to get rid of the square roots, I could just multiply the top and the bottom by the square root of 2. That way I'm not changing the value of this fraction. But if I multiply straight across the way I do when I multiply fractions, the square root of 2 times the square root of 2 leaves me with just a 2 in the denominator. So in the numerator I have 2 root 2, and in the denominator I have a 2. I can actually take that a step further. I can cancel out this 2 and this 2, and I'm left with just the square root of 2 for my final answer. So at this point I've rationalized, but I haven't reduced the fraction. To reduce the fraction I'd have to get to here. What about the next one? Well, you could do the exact same thing we did here. You could multiply the top and the bottom by the square root of 27. Or you could say that the square root of 27 is 3 to the 3rd power. So it's the square root of 3 cubed. If I do my good radical, bad radical trick, I could put 2 of those 3's over here and have one of them over here. And the square root of 3 squared is just 3. In other words, this is just the square root of 6 divided by 3 times the square root of 3. That's where that came from. And then to rationalize the denominator here, I don't have to multiply the top and the bottom by the square root of 27. I could just multiply the top and the bottom by the square root of 3. I could say root 6 divided by 3 root 3 times root 3 over root 3 gives me, let's see, in the top I would have the square root of 18. And in the bottom, I would have 3 times root 3 times root 3. So I'd have 3 times 3. So I'd have the square root of 18 over 9. However, the square root of 18 is 3 root 2. So I'd have 3 root 2 over 9, which can reduce to root 2 over 3. So right here would be my final answer. I think I owe a little bit of justification. Kind of like I did here, I should say that the square root of 18 is equal to the square root of 3 squared times 2. So on the good side, I'll put the 3 squared. On the bad side, I'll put the 2, and I'll get 3 root 2. So this is 3 root 2. And so that 3 root 2, I think these arrows are starting to make things worse, goes there. All right, moving on. Solve the following radical equation. The trick to solving radical equations, there's kind of a couple tricks to tell you the truth. But the first thing is you just want to get rid of the radical. Essentially, the way you can get rid of the radical is by squaring both sides of the equation. However, if you try to square both sides of the equation now, the radical won't just cancel out because I have this minus 1 right here. So first, isolate the radical. Then, so add 1 to both sides of the equation. So now that I've isolated the radical, now I can square both sides of the equation. The square root of x plus 7 squared is just x plus 7. If I square this side, I got to square this side. On this side, I got x plus 1 squared. Now I have an equation that doesn't have any radicals in it, so presumably I can solve it. Let's see, x plus 7 equals, if you expand this all out, x plus 1 times x plus 1, you get x squared plus 2x plus 1. So if you want to solve an equation that has x squared terms in them, set it equal to 0. Subtract x from both sides, subtract 7 from both sides. And get 0 is equal to x squared plus x minus 6. And the way you factor this once you set it equal to 0, the way you solve this is by factoring. So to factor the left-hand side here, I need two numbers that multiply to negative 6 and add to positive 1. Those two numbers are positive 3 and negative 2. So what I have is either x plus 3 equals 0 or x minus 2 equals 0. The only way I can multiply together these two things and get 0 as my answer is if either this one's 0 or this one's 0. So either this is true or this is true. X plus 3 equals 0. If I subtract 3 from both sides, I get x equals negative 3. X minus 2 equals 0. If you add 2 to both sides, you get x equals 2. If you got to this stage, I'd be pretty happy. However, one thing that you have to remember when you're solving radical equations is you always have to check your answers. Always. Not to see if you made a mistake, but to see if information was lost in the process. What I mean by that is take your answer of negative 3 and plug it in. The square root of negative 3 plus 7 minus 1, does that really equal negative 3, question mark? Well, let's see. Negative 3 plus 7 is 4. So I have the square root of 4 minus 1. I don't think this is going to work because the square root of 4 is 2. And 2 minus 1 does not equal negative 3. What that means is negative 3 is not a solution. What about 2? So this is checking x equals negative 3. Now we'll check x equals 2. Square root of 2 plus 7. Minus 1. Is that equal to 2? Let's see, 2 plus 7 is 9. So I got the square root of 9 minus 1. The square root of 9 is just 3. 3 minus 1, yep, that equals 2. Looks good. So I got one of them to check, one of them doesn't. X equals 2 would be my only solution. I guess that's it. That's the end of this quiz.